Very good afternoon, dear students. Welcome to the live virtual classes organized by the Board of Studies Academic ICAI. Today we are taking up Chapter 14 Measures of Central Tendency, the second part of Unit 1. So I welcome once again all the students who have joined today in the session. And in the last session, we had covered the first part of Unit 1. And there we were discussing about central tendency. So a quick recap of the major points which we had discussed in the earlier session. First, you will remember that central tendency means the descriptive summary of a data set. And as we explained that in case of any distribution of numbers, any statistical distribution, the different numbers try to circle around a central figure, a central value. So this central value is what is meant by central tendency. And it reflects the center of the data distribution. Okay, now we move to the next point, that the measures of central tendency, as we had covered, primarily we have talked about mean, median, and mode. And when we talk about mean, we are referring to arithmetic mean. So in the last session, we had discussed about the properties of mean, median, and mode, the formula, and the process of computation, both for simple distribution as well as for grouped frequency distribution. Plus, we had been discussing about the advantages and the disadvantages of these three measures of central tendency. And arithmetic mean, you will recall, is where we divide the sum of the elements of a set of numbers by the value, so the number of the values divided by the number of observations. And then median is a positional average, and it's the middle value of the data set. We talked about the process of computing mean as well as median in different circumstances. And last one was mode. The mode, as we have discussed, and you must have remembered the discussion, that the mode represents the frequency. So that value which has the highest frequency, that value will be regarded as the mode. But there may be a set of distributions where it could have one mode, or it could have two modes, or even more. Data sets can therefore contain multiple modes, and in certain scenarios, there may not be any mode. So these type of situations can also arise. And of course, apart from mean, median, and mode, we had covered detailed discussion on the quartile, percentile, and decile, as well as the process of calculation and what is the concept of these measures of central tendency. Today, we are taking up the last two important points, and that is geometric mean as well as harmonic mean. So we will first talk about the concept of geometric mean. And in the recent sessions, you had covered geometric progression, arithmetic progression. So already you have a good idea about what is geometric progression, and therefore the concept of geometric mean will become very easy to understand. We shall be discussing about the properties of both geometric mean as well as harmonic mean. And like any measure of central tendency, there are certain advantages as well as disadvantages of each of the measure. And at the end, we will talk about the process of computation. A number of questions we shall be taking from the set A and set B of the exercises. Apart from that, important questions of the last few years from the mock test paper as well as the revisional test paper will be discussed in this session. So the learning objective, once again, you see, is to understand different measures of central tendency, starting with arithmetic mean, median, quartiles, mode, and within the arithmetic mean, Within mean, in fact, when we talk about average, apart from the AM, we also have geometric mean and harmonic mean. So to understand the computational techniques, in which scenario we can use which type of method, for example, geometric mean will be used in specific scenarios. Harmonic mean deals with cases where we have to find out when we are dealing with, say, certain rates, speed, for example. Similarly, when we talk about the CAGR, the annual growth rate calculation, or when we are dealing with interest rates, investments, there geometric mean might be more appropriate. So we shall understand the computational techniques, the objectives, and how to use, when to use which type of central tendency measure. So this is going to be very important for you, and number of questions are coming from this particular chapter, which covers a broad area of central tendency. And this is only the first unit, unit 2 of chapter 14. We will move later, and that deals with the entire spectrum of dispersion. Now we start with geometric mean. So if you look at 14.1.6 of the study material, this section, you can see that geometric mean, many of you might already have gone through this study material. You might have a good idea about this concept. So geometric mean is a scenario, a situation where we want to find out that, okay, arithmetic mean, we know the sum of two numbers. Say there are two numbers A and B. We want to find out the arithmetic mean. So we just simply add A plus B divided by 2. We get the arithmetic mean. But in case of geometric mean, if a variable x is assuming different values x1, x2, x3, but then you see the first condition here is that all the values have to be positive. If any of the value is negative, then geometric mean cannot be computed. Similarly, if any of the value is 0, then also geometric mean will not be the appropriate measure. So here you see in this particular part of this chapter in the study material, it is very clearly mentioned that if a variable x assumes different values, n number of values, all the values being positive, then the geometric mean is given by, first what we do, we find out the product of all these numbers, and then we find out the nth root of the product. So you can see 14.1.11 and 14.1.12, which gives us the important formula for the purpose of computing the geometric mean. So geometric mean is, many of you, when you think about geometric progression, you will see that geometric mean and geometric progression are based on the same foundation. So therefore, the geometric mean is definitely, we can say it is definitely a measure of central tendency. Just like arithmetic mean, geometric mean is also a measure of central tendency. So it is the average value or mean which signifies the central tendency of a set of numbers. And here, what we do is we multiply all the numbers and then take out the nth root. So if there are n numbers, or say let us take a situation where we have 5 numbers and we want to find out their arithmetic mean. We simply add the five numbers and divide the sum by 5. But in this case, we are multiplying those 5 numbers and we get a product, and the geometric mean is the nth root of that particular product. So this is where geometric mean differs from arithmetic mean. Now, in which scenario, in which situation do we use geometric mean? Arithmetic mean, we have already discussed. It is used in a variety of practical scenarios. And of course, it is easy to understand, easy to calculate. Even in case of grouped frequency distribution, it is relatively easy. But geometric mean, can we think of a practical case or a particular scenario where geometric mean is the most appropriate measure of central tendency? Yes, we talk about the use of GM or geometric mean, and we see a particular case of investments. Now, in the course of your journey in the chartered accountancy, in different levels, intermediate and final, financial management, you will deal with a lot of problems involving investments, and both in intermediate level as well as in the CA final level, there is a paper on financial management, advanced financial management, where you shall be required to find out the return from a particular investment. It could be investment in a bank, a fixed income investment. It could be something like, say, for example, a particular investment in the capital market, a mutual fund investment. So, investment and the returns. Now, of course, we know that the returns might fluctuate over time. Even when you talk about bank fixed deposits, the interest rate on fixed deposits keeps changing from year to year because the RBI will revise the interest rates, and as a result, the commercial banks will keep on changing the rates. So in a span of 5 years, for an example, the interest rate on a particular deposit in a bank might not be the same. It will change from year to year. Similarly, in case of any investment which is market linked, you will have different rate of return. So in financial management, in investment, a critical area is to think of, is to calculate that, okay, if my investment is earning different rate of return over the last 3 years or 4 years or 5 years, I must find out what is the average rate. What is the representative rate? Because interest rates will move up and down. Return on investments will never be the same. But we need to find out the average rate of return. Many of you, dear students, you are aware about a term which is called ROI, return on investment. So we have one such case on this slide where you see that an investment is earning 10% return in the first year. In the second year, it is earning 60%, and in the third year, it earns 20%. The question is, what is the average rate of return? Now here, if we apply arithmetic mean, what will be the average rate? So what we shall do is, we will, year 1, the return is 10%, year 2 it is 60, and year 3 it is 20. So I will add up all these three numbers, 10 plus 60 plus 20, and I am getting 90. And since the number of years is 3, so I divide by 3. And I get the average or the arithmetic mean. 90 by 3, it comes to 30%. But is this the right indicator? Not really. And that is where the logic, the reasoning comes up like this. Now here, arithmetic mean seems to be the easiest option. But then here, if you see the investment in the first year, it's earning 10% return. So here the reasoning is like this, that the investment is multiplied by 1.10 because 10% is the return on the investment. Similarly, the second year, it is multiplied by 1.60. Why? Because we have a 60% return. And in the third year, it is multiplied by 1.20 because, as you can see on the slide, the third year rate of return is 20%. So therefore, since we are dealing with rate of return, geometric mean of these three numbers will be the most appropriate measure of central tendency. So dear students, as we were discussing in the previous session, that central tendency is represented or denoted by different measures. Mean is one of them. We have median, we have mode. Also, there are different types of mean: arithmetic mean, geometric mean, and harmonic mean. That means depending on the situation, depending on the facts of the case, we have to apply different methods. So in this case, which deals with investment, the question is that what is the average rate of return, and therefore we can a little change the question by saying that by what constant factor would the investment need to be multiplied each year to achieve the same result. So here what happens, first year the investment gets multiplied by 1.10, second year it gets multiplied by 1.60, and third year 1.20. So the multiplier is different for different years. But here the moot question is that what constant factor, if multiplied year on year, will give us the same effect. What effect will I get when I multiply the investment by 1.10, 1.60 in the second year and 1.20 in the third year? Whatever effect I get, the same effect I must get when we think of a constant factor. This constant factor is the geometric mean. And therefore, in this example, if we calculate the geometric mean of these three rates, that is, we have in the first year we have 10%, in the second year 60%, in the third year we have 20%. So if we find out the geometric mean, that means we multiply all the three rates, 10%, that is 0.1, into 0.6, into 0.2, we get a product. We have three numbers, we have got the product. So therefore, we have to now obtain the third root, that is cube root, because here the number of observations is 3. And the geometric mean gives us approximately 1.283, which indicates that the average rate of return is around 28%. But as I discussed earlier, arithmetic mean gives us a figure of 30%, but geometric mean is more appropriate, more precise. So when we talk about central tendency, accuracy and precision is an important factor, and geometric mean serves that particular purpose in this scenario. So dear students, please remember that when it comes to any problem, if you receive any situation, any problem where there is a question of rate of return, geometric mean will be the most appropriate measure to use. Now we look at some of the important properties, after which we will move to the solved examples. So looking at the properties, that means we see that geometric mean is the nth root of the product of the different numbers whose geometric mean we are trying to find out. Now, if you look at the product, one important property, the product of the ratios of the n observations is always unity. Now, if you look at this example, this particular property number 3, specifically on the slide which we see, the product of the ratios of each of the n observations to the geometric mean will always be unity. Unity means 1. That means what this property is saying, that we have numbers, say n numbers, x1, x2, x3, it goes on up to xn. And say the geometric mean is g. So geometric mean g in this case is what? It is the nth root of the product x1 into x2 into x3 till xn. So therefore, if you just see the next step on the slide, so x1 divided by the geometric mean g multiplied by x2 divided by g, if you do that, what you get is, in the numerator, you get x1 into x2 into x3, which is nothing but what you get is, that is basically g to the power n. And in the denominator also, you get g multiplied n times. That means in the denominator again, we get g to the power n. So this gives us a ratio of 1. Next important point we see here is the logarithm of g, because here the GM, the geometric mean, is the nth root. So therefore we have a logarithm. So when we see that g, geometric mean, is the nth root, that means log g will be equal to 1 by n into sigma log x. So this is another important property and feature. The third important point is the geometric mean of the product of two variables. So let us say there are two variables x and y, and the product of x and y is z. So you have z equal to x multiplied by y. So if z is equal to xy, then, and we know the geometric mean of x and the geometric mean of y, can we calculate the geometric mean of z? Answer is yes. So the geometric mean of z will be simply the multiplication. You just need to multiply the geometric mean of x and geometric mean of y. So the geometric mean of z is the product of the geometric means of x and y. Similarly, when we have another case, the geometric mean of the ratio of two variables will be simply the ratio of the GMs of the two variables. That means if z is equal to x divided by y, this is just opposite to the last scenario where we saw that z is equal to x multiplied by y. So now we are getting z is equal to x divided by y. So the geometric mean of z will be simply equal to the geometric mean of x divided by the geometric mean of y. So I hope you have understood this. These are very simple basic postulates and properties of geometric mean. And of course, we will now move on to see some of the examples. One small point here, which I will draw your kind attention to that. So a small problem I've given on the lower part of the slide. It reads like this, that if A, G and B are in geometric progression. So all of you are having good understanding of geometric progression. You know that if A, B, C are in GP, in geometric progression, so we have the same common ratio. So the question is, if A, G and B are in geometric progression, then G is considered as what? Arithmetic mean? Is it the geometric mean? Is it the standard deviation? Or is it none of the above? So you are all, I'm sure, understanding, and you must have arrived at the right answer. It is geometric mean. So A, G and B are in geometric progression, which means the first term is A, the second term is capital G, and the third term is B. So if A, G and B are in geometric progression, that means G divided by A has to be equal to B divided by G, because it's a common ratio. Term 2 divided by term 1 has to be equal to term 3 divided by term 2, and so on. So if G divided by A equals B divided by G, you just go for a cross multiplication. You find G square is equal to A into B, which means if G square is AB, then G is what? The square root of A and B. And this is precisely the definition of geometric mean. So here G will be the geometric mean. Now we move on to some examples. We will see the first one coming up, and these are fairly easy ones. 14.1.13 from the ICAI study material. The question reads, find the geometric mean of 3, 6 and 12. So fairly simple question. So we know the formula of geometric mean. We have also discussed about the main important principles and the properties of geometric mean. So applying the formula, what do we get? So what we are getting is we have got three numbers, 3 into 3, 6 and 12. So we will find out the geometric mean. It will be the third root or the cube root of the product of 3, 6 and 12. That is 3 into 6 into 12, the cube root of this product. And if you see the working out, it comes to 6. The second question we see is where we have some frequencies. This is 14.1.14. So here we have certain numbers, so variable x, 2, 4, 8 and 16, and each of the value has a particular frequency. So in this scenario, how to find out the geometric mean? So the formula is the geometric mean will be, in this case, x1. Here x1 is 2, x2 is 4, x3 is 8, and x4 is 16. So these are the different values of the variable which x, the variable x, and the different value which it can take up. So now here we are going to use a different approach. So when we have numbers, variables along with frequency, corresponding frequency, then what we are doing here is the product, the geometric mean now becomes the nth root, but here we are using x1 to the power f1. So we are using indices, the law of indices, which you have already covered earlier. So x1 to the power f1 multiplied by x2 to the power f2 and so on. That means the variable and the frequency will now come to the index position. So 2 to the power 2, because the first value is 2 with a frequency of 2. So 2 to the power 2 multiplied by 4 to the power 3, because here we see the second value is 4, but it has a frequency of 3. Similarly, we multiply this by 8 to the power 3, because the third observation, the third value 8, also has a frequency of 3. And then we multiply it by 16 to the power 2, because 16 is the fourth value with a frequency of 2. Now, if you add up all the frequency, that is sigma f, you are getting 2 plus 3 plus 3 plus 2, that is 10. So here the solution therefore is the 10th root of this particular expression, 2 square into 4 cube into 8 cube into 16 square. If you calculate this, you will find it will come to 2 to the power 25 just by applying the formula which you have learned in indices. A to the power m into a to the power n gives you a to the power m plus n. Similarly, a to the power m to the power n, that means it gives us a to the power m into n. So applying the basic rules of indices, we will arrive at 2 to the power 25, but we have 1/10 in the power position. So therefore, it comes to 2 to the power 2.5, which when further simplified gives us 4 into root 2. So the answer comes to around 5.66. So this is the geometric mean process of calculation in a case where we have different values and corresponding frequency for each of the values. Okay, so we have covered the two important formula, one in case of a series of variables without any frequency, and the other in case of a series of variable which has frequency. Now we move to the next slide and we will see, before this, moving to the next slide, yes, two important notes. Perhaps I was discussing this earlier as well, that in case of geometric mean, as we have earlier deliberated, every measure of central tendency has certain advantages as well as disadvantages. Nothing is perfect. None of the central tendency measures are perfect. Everyone has some pros and cons. Geometric mean works out perfectly well in specific scenarios, especially which involves rate of return. But Please note, ultimately geometric mean is calculated by multiplication and then taking the nth root. And we know that when we take the nth root of any number, that number has to be positive. For example, square root of 64, yes, you know 8 square is 64. 125, if I ask you what is the cube root, you will say, okay, 5 into 5 into 5. So cube root of 125 is 5. But if we get a value like, say, minus 49, what is the square root of minus 49? This will give us imaginary roots. Even in quadratic equation, you may remember when you were solving problems on midterm factorization. So there were situations given to you where you had to find out from the equation ax square plus bx plus c equal to 0. You may remember that the value of x comes to minus b plus minus square root of b square minus 4ac by 2a, provided that b square minus 4ac, if b square minus 4ac is equal to 0, then you get two distinct roots. But if b square minus 4ac is less than 0, then you get imaginary roots. You will not get real roots. Similarly, in case of geometric mean, if any of the value in the given data set, if it is negative or 0, then GM, the geometric mean, cannot be calculated. Now, you can call this as a particular limitation or maybe a disadvantage of GM, but it is a fact. Similarly, if the given data is open-ended distribution, then the value of the GM, the geometric mean, cannot be obtained. Why? Because just like arithmetic mean, please note that geometric mean is calculated with reference to all the values which are given. Please think of median. We have discussed at length about median. Median means middle value. So median is particularly helpful in case of open-ended distribution because median is not bothered with the last class or the last value. Even if it is open-ended, doesn't make a difference. But in the case of geometric mean, if there is an open-ended distribution, then the value of GM cannot be obtained simply because, just like arithmetic mean, geometric mean relies on all the values. In case of arithmetic mean, we add up all the values, then divide it by the number of observations. So please mark my words, we add up all the values given in the particular data set. In geometric mean, what are we doing? We are multiplying all the values which are given, and then we are finding out the nth root. That means in both AM, arithmetic mean, as well as geometric mean, we are dealing and we are including, we are considering all the values given in the particular data set or in the distribution. So please remember these two critical points, that if any value given in the data set is either negative or 0, if it is negative, what will happen? The entire product will be negative. Now the square root or the cube root or the nth root of a negative number means it will be imaginary. It cannot be a real root. Similarly, GM or geometric mean deals with the product. Calculation is done by multiplication. So you have 4 distinct values, we multiply the 4 values. But if out of those 4 values, one of the value is 0, then the entire product becomes 0. Because you know any number multiplied by 0 will give us 0 itself. So these are two important constraints, limitations, and we need to be careful that if in any problem we find, in a given scenario, if we find that one of the variable has negative, that means is negative, is less than 0, or it is equal to 0, then GM, geometric mean, may not be the appropriate or the right measure of central tendency. We have to think of other measures. We have AM, we have GM, we have HM, harmonic mean, median. We might think of using mode. But GM, geometric mean, will not be the correct approach in case any of the values in a given data set is either 0 or negative. Similarly, point number 2, as you can see, if the given data set is open-ended, that means here GM cannot be obtained. Why? Because for GM calculation, all values and all class intervals, all the values given in the class intervals are required. So these are 2 limitations. We now look at the next point, the advantages. And of course, we will look at the other disadvantages as well. First advantage, it is not influenced by the extreme items to the same extent as mean. So mean gets affected to a larger extent by extreme items. In the last session, I was giving an example of extreme value, extreme items. Definitely, arithmetic mean has a higher level of fluctuation. The AM will fluctuate wildly if there are few extreme observations present, extreme values. That means we have few numbers, say 10, 14, 31, and then suddenly 1500. 1500 is an extreme value. So the moment I calculate the AM, the arithmetic mean, it will fluctuate. It will show a higher level of susceptibility due to the introduction of that particular number 1500, because it is an extreme value, extreme item in the data set. In case of geometric mean, there will be certain effect. Even GM will be affected, but not to the extent of arithmetic mean. So geometric mean is more stable and it is not going to be influenced by extreme items, extreme values to the same extent as arithmetic mean. So please remember this important point. Yes, number 2 advantage is geometric mean is very clearly, rigidly defined. So in the first day, in the beginning of the chapter 14 discussion, we were explaining the characteristics of an ideal measure of central tendency. And there, one of the criteria was that the particular measure or the formula should be clearly understandable. It should be rigidly defined. Very clearly, precisely defined without any scope of confusion or ambiguity. So geometric mean definitely meets this expectation. It is defined in a rigid manner. There is no room for any type of confusion or misunderstanding. And the value we arrive at is a precise figure. Plus, just like arithmetic mean, geometric mean is based on all observations. Plus, it is further amenable, it is capable of further algebraic treatment, analysis, interpretation. Plus, the unique feature of geometric mean, the feature where geometric mean scores above arithmetic mean, in which cases, when we are finding out the average rate of the growth of the population, that means here we are dealing with rates, growth rates, bank deposits attracting compound interest, and then depreciation. Very important point in accounting is depreciation calculation. Already in your accounts, you are doing problems on depreciation, capitalization, fixed asset, property, plant and equipment, as we call them. And you are all aware about the methods of depreciation, straight line method and written down value, the process of diminishing balance method, and so on. Now, in case of depreciation calculation using diminishing balance method, geometric mean is found to be the most precise and the most appropriate measure of central tendency when we want to find out the average rate of depreciation. Next, we have another advantage. Yes, index numbers. One of the last chapters towards the end, we have the chapter on index number. Probably it is the last chapter of our curriculum. Before that, we have correlation regression, and the last chapter is index number. And there, when we discuss about index numbers, you will recall that there are different type of index numbers. And of course, index numbers best understood when you think of the stock market index. The BSE Sensex or the NSE Nifty is an example of index number. Plus, all of you are aware about wholesale price index, consumer price index, and so on. So index number is yet another highly practical chapter of statistics which has a wide application in economics, also in finance, in public finance as well, not just corporate finance, even in public finance. So there, one of the index number we have is Fisher's index number, and the Fisher's index number, which is also known as ideal index number because of certain key attributes, key qualities, that Fisher's index number is nothing but the geometric mean of two other index numbers, last previous index and past year's index. So we can see the direct application, the use of index number of geometric mean in the domain of index number. So this is how concept which we learn in one particular chapter of quantitative aptitude. For example, the concept and understanding of geometric mean, which we are absorbing through these sessions, you will find a direct application of the principle of geometric mean even in the discussion of index numbers. So in one way, we can say many of the chapters, a number of concepts, principles, formula, these are related. So therefore, no doubt about it, geometric mean has a number of advantages. Now, disadvantages. Obviously, one or two disadvantages are there, and we were referring to it earlier in the earlier slide. So before we move to that particular disadvantage, another disadvantage which is very commonly pointed out is that geometric mean is not so easy to calculate. Yes, it is true. In case of arithmetic mean, even if you have 10 different variables, 20 variables, 50 variables, yes, you just simply add up and find out and divide by 50. Say there are 50 numbers, you get the total sum, and then divide by 50, you get the arithmetic mean. But in case of geometric mean, if we are given 50 numbers, we have to multiply all of them, and then we need to derive the 50th root of the product. So it is definitely true that geometric mean is not easy to calculate, and for many students or many professionals, maybe geometric mean for the common man, well, it may not be easy to understand as well, especially if we will look at a distribution. You have some variables, and for every value we have a frequency. So what we did is the number to the power, we are adding the frequency x1 to the power f1 into x2 to the power f2. So well, this seems to be little difficult or challenging for the purpose of understanding. Next is, yes, the most critical disadvantage, limitation, or you can call it a constraint, that in case of a series of observations, if any of them is zero, geometric mean is zero, and therefore it will not be determined. And at the same time, if any of the value in a given set of numbers, observations, variables is negative, then geometric mean will not give us real roots or real numbers. It will become imaginary, and it may not serve any practical purpose. So there might be scenarios when we look at the return on investment. Well, sometimes there might be negative returns. It is possible, even though not desirable. No one wants a negative return on investment. But yes, due to severe geopolitical crisis, due to a lot of risks in the business world, financial markets can get adversely affected. And yes, an investor might end up getting negative returns. But if any return is negative and we want to calculate the geometric mean, then it will give us wrong indicator, because geometric mean calculation of a set of value, and even if one of the value is negative, the product becomes negative as well, and therefore it will give us imaginary numbers. So these are some of the disadvantages of GM. Now with this, we move to the last important parameter or measure of central tendency, and that is harmonic mean. So harmonic mean has specific applications. So in which areas or in which type of problems should we apply harmonic mean? So what the golden rule says is, it's like a gold standard, that use harmonic mean in case of finding averages involving rate, time, price, and any type of ratio. So these are the usual sectors or scenarios or cases where harmonic mean can be used safely, and it will give us positive response, it will give us meaningful outcome, and which will be understandable by us. Now, first we, just like we were referring to geometric progression and then we move to geometric mean, we apply the same process. So first we see what is harmonic progression, and then we will look at harmonic mean. So as you can see on the slide, harmonic progression is a sequence of numbers such that if the reciprocal of these numbers are in arithmetic progression, then it is known as a harmonic progression. That means if there are terms of a series T1, T2, T3, now these numbers T1, T2, T3, T4 up to Tn will be in harmonic progression only when the reciprocals of these numbers, that is 1 by T1, 1 by T2, 1 by T3, the reciprocal of these terms, if they are in arithmetic progression, AP, then only T1, T2, T3 will be in harmonic progression. So this is the meaning, the concept of harmonic progression. So therefore, if there are three terms, T1, T2, and T3, three values, T1, T2, and T3, and we know that 1 by T1, 1 by T2, and 1 by T3 are in arithmetic progression. That means the reciprocal T1, T2, T3, the original numbers. So reciprocal of these numbers are in AP. So the original numbers will be in HP, that is harmonic progression. So how do we find out the harmonic mean? So now we can see on the right hand side of the slide the formula as given in the study material for a given set of non-zero observations. Please note very carefully, non-zero observations. Non-zero means the numbers in a data set, none of them should be zero. We will understand this little later. Please note, similar condition was given in the definition of geometric mean, and we saw that if in case of calculation of geometric mean, even if one of the element, one of the number, one of the variable is zero, the entire product will be zero. So what is the use of taking the nth root of zero? Similarly, in case of harmonic mean, if a variable x assumes different values but not zero, say the values are x1, x2, x3 up to xn, then what is harmonic mean? Harmonic mean will be equal to n divided by sigma 1 by x. That means 1 by x plus 1 by y plus 1 by x1 plus 1 by x2, it will go on, because these reciprocals are in arithmetic progression, and in the numerator we will have the total number of observation, which is n. So therefore we see that T1, T2, T3 will be in harmonic progression only when 1 by T1, 1 by T2 are in arithmetic progression. So I hope you have understood this. And the harmonic mean, as you can see, is when we have three terms, that is n equal to 3, and the terms are T1, T2 and T3. The harmonic mean is given by, in the numerator we have the number of terms, that is 3, and in the denominator we are adding the reciprocals of the three given numbers. So we are given three numbers, T1, T2 and T3. In the calculation of harmonic mean, in the denominator, what we are doing is we are adding 1 by T1 plus 1 by T2 plus 1 by T3. That means we are adding the reciprocals, or the inverse, you can call it the reciprocals of the given numbers. That means here, if you see why the study material in 14.1.16, as you can see, why it is given in the very beginning that harmonic mean can be calculated only for non-zero observations. It is clearly written that for a given set of non-zero observation, that means none of the observation can be zero. Because if any of the observation becomes zero, what happens is we are finding out the reciprocal. So if a particular observation is zero, then the reciprocal becomes 1 by 0. Now we know 0 by 5 is 0, 0 divided by 1 is 0, but 1 divided by 0 is undefined. So therefore, to avoid this fallacy, the requirement is very simple, that a given set of observations should be non-zero. None of them can be, if any of them is 0, then it will not give a meaningful result. And that is the reason why the study material, the definition clearly says that if a variable x assumes n non-zero values, x1, x2, x3, it can be negative. The value can be fractional, but need not or should not be 0. So this is the concept of harmonic mean. And this is the formula which we all need to know, learn, and thereafter apply that if questions come in the exam. Now, as I was mentioning earlier, that harmonic mean is used in specific cases like rates and ratios, and specifically in cases like ratio, like price earnings ratio, one of the very common ratio. Many of you who are interested in investing and you have understood the basic financial statement ratios. So many of you understand what is EPS, earnings per share. So another ratio is price earnings. Price earnings means the market price of a share divided by the earnings per share. That is called price earnings ratio, or sometimes price earnings multiple. So if there is any problem, any numerical problem involving rates, ratios, specifically price earnings ratio, in this particular case, harmonic mean will give us the most correct value. So we can see the relative advantages of arithmetic mean, geometric mean, and harmonic mean. Plus, we are parallelly analyzing the disadvantages and the restrictions. That means what are the cases where we cannot use geometric mean. For example, if any of the observation is 0, or if it is negative, we cannot use geometric mean. If any of the observation is 0, then harmonic mean should not be used. Right? I hope you are able to understand and follow the session. We have one more example. In situations involving time and distance, speed, average speed calculation. Now, in situations like certain industries, quick commerce. Quick commerce means how quickly you are able to deliver the product to the customers, and we are all using quick commerce. It is a part of our daily life. Now, in quick commerce industries, a very critical parameter of performance is the speed of delivery. How fast we are able to deliver to the customers, last mile connectivity. Similarly, in the transportation industry, mobility sector, mobility industry or transportation industry, in the supply chain domains, speed calculation, average speed calculation is a very significant operational indicator. That means how efficiently I am able to utilize my resources, how quickly I am able to deliver goods, how quickly I am able to transport shipments from one point to the other. Even in civil aviation, this is a very important, the average velocity or the speed. So the vehicle, it's given in this problem, a vehicle is traveling a specific distance, say at 60 kilometers per hour, and then travels again the return journey at 40 kilometers per hour. So in these type of scenarios where it involves time and distance, speed as you know is distance divided by time. So in these type of calculations, harmonic mean is the most appropriate. It will give us the most accurate result. Finally, we see that the harmonic mean for an observations, as you saw, is therefore 5 observations, x1, x2, x3, x4, x5. So 5 observation. In the numerator, we will put 5, divide it by the sum of the reciprocals. That means x1 now becomes 1 by x1 plus 1 by x2 plus 1 by x3 plus 1 by x4 plus 1 by x5. That will come in the denominator. So this is the entire understanding of harmonic mean. And the last formula which you need to remember for your exam is that just like the case of arithmetic mean and geometric mean, similarly, in case of harmonic mean, there can be frequencies. So in case of a frequency distribution, what we do in the numerator, we will have the total frequency capital N, but in the denominator, what we will do in the denominator, if you see sigma Fi(xi), that means the frequency divided by the first variable, frequency of the first variable divided by the value of the first variable, plus frequency of the second variable divided by the second variable. Like this it will go. So this is the only difference we have between geometric mean and harmonic mean, specifically the formula number 1, which gives us the basic indicator of the ratio. And number 2 is when we have frequencies, in case of grouped or frequency distributions, what will be the formula? Yes, these are the 2 methods or the 2 variations of the cases of group frequency distribution. One is for GM, one is for HM. We are now taking some practical examples. Example 17 from the ICAI study material. The first one on the slide. We have to find the harmonic mean of 3, 6, 12 and 15. Right. So 4 numbers are given, 3, 6, 12 and 15. So as per the definition of harmonic mean, we invert or we find the reciprocal of the numbers. So 1 by 3, 6 becomes 1 by 6, 12 becomes 1 by 12 and 15 becomes 1 by 15. So in the denominator, you can see we are adding the reciprocals 1 by 3 plus 1 by 6 plus 1 by 12 plus 1 by 15. In the numerator, we have the total number of variables. Here it is 4. So rest of it, you can see it's very clearly calculated on the slide. You can see 4 divided by this particular sum and it results in 6.15. The answer is 6.15. So the harmonic mean comes to 6.15. Now we have another very interesting question. Example 18 from the study material. Find the harmonic mean of 1 half, 1 by 3, and it goes on to 1 by n. That means there are n numbers. So harmonic mean, the numerator, in the numerator we put the total frequency. We show the total frequency in the numerator. Fine. So here also we will write n in the numerator. In the denominator, the given numbers will be inverted because we need to find the reciprocal of the numbers when we are calculating harmonic mean. So in the denominator, we will have 1 plus 1 by 2 was the original number. So we need to find the reciprocal. The reciprocal of 1 by 2 will become 2 itself. Similarly, the reciprocal of 1 by 3 will become 3. In this way, the reciprocal of 1 by n will become n. So dear students, in the particular denominator, if you see here, numerator is clear, n. But in the denominator, after the reciprocals are added, we are getting 1 plus 2 plus 3 up to n. So you know this is a formula which you have learned earlier in the session of arithmetic progression. And you may remember that in that particular chapter, you were supposed to find out the nth term of a series and the sum of the series. So in the same context, 1 plus 2 plus 3 up to n, the formula will be n into n plus 1 by 2. So here in this way, if you just add up and if you just do the simplification, you end up getting 2n divided by n into n plus 1. After cancelling n, you will get 2 divided by n plus 1. So this is a very interesting question from the study material. Now we see the third example, number 19. This is a question on speed. That means it is a ratio. Speed is a ratio of distance and time. So the question, you can see a motor car covering distance of 50 miles 4 times. First time it is 50 miles per hour. The second one is 20 miles per hour. The third time it covers is 40 miles per hour. And the fourth is 25 miles per hour. We need to find the average speed and explain the choice of the average. So here definitely it's a question of speed and it's a ratio. So according to our basic parameter of central tendency, in these type of cases, harmonic mean will provide the best results. So harmonic mean will be the absolute choice from the point of view of precision and realistic output. And as a result, consequently, there are 4 values given: 50, then 20, 40, and 25. So we have 50, 20, 40, and 25. So there are 4 values given. So in the numerator, we have 4. In the denominator, we are adding up the reciprocals of these numbers. Consequently, it comes to 29.63, which can be rounded off as 30. So therefore, we see the logic for the statements into units per hour when the different values of distances are given. To find the average, it is always the harmonic mean which is used. So as a result, we have used harmonic mean in this case because we are given distance divided by time. Speed is ultimately nothing but distance divided by time. So it's a ratio. So this is the logic. And now we see the last example before we move to the exercises. So we see 14.1.16 here. Find the harmonic mean for the following data. We are given data, values of x, 2, 4, 8, and 16, and we have been given the corresponding frequency. So x is assuming 4 different values and with 4 frequencies. So using the formula for grouped frequency distribution, we are getting the harmonic mean here. The total frequency is 10. So capital N becomes 10. And we know the numerator is, in case of harmonic mean calculation, the numerator is nothing but the total frequency. So here we put 10 in the numerator. In the denominator, the formula was sigma fi xi, fi divided by xi. That means in the numerator, come to the denominator part, you see some fractions. In the denominator, with regard to the fractions in the denominator, for each of the fractions, the numerator here signifies the frequency and the denominator is nothing but the reciprocal of the original values of x. Consequently, for the first value which is given x equal to 2 and the frequency 2, so now in the denominator, in the first fraction, it is written 2 by 2. That means the frequency 2 goes to the numerator and the reciprocal given, the reciprocal of x is equal to 2. So the reciprocal of x is 1 by 2. So therefore 2 divided by 2, 2 by 2. Similarly, the other numbers, the other fractions are also derived in the same manner. And proceeding through the problem, we get the harmonic mean coming to 4.44. The last one given, example 21, we have the harmonic mean of 1 half, 1/3 and 1/4. So there are 4 numbers. In the numerator, we will put 4. In the denominator, we are simply adding the reciprocals of these numbers. So the reciprocal of the first number is 1 itself, 1 by 1 you can say. And then we have the reciprocals are given and then we just add them up. You can see what we are doing is we are adding the reciprocal. So half will become 2. 1 by 3, this particular number, once we find the reciprocal, it will become 3. And 1 by 4, which is the fourth value given in this problem, the reciprocal is 4. So therefore we get numerator is number of variables 4. So numerator is 4. In the denominator, we are getting 1 plus 2 plus 3 plus 4. Consequently, we are getting 4 by 10, which equals 2 by 5. Right? So I'm sure you have understood and followed this. We are going through each and every important example from the study material after we have discussed the concept, the formula, the need for all the different types of measures of central tendency, both for geometric mean as well as for harmonic mean, which we have covered today. Now we are proceeding to the advantages of harmonic mean. So just like AM, arithmetic mean and geometric mean, every measure of central tendency will have pros and cons. So for harmonic mean, yes, the first advantage that just like arithmetic mean and geometric mean, harmonic mean is based on all observations. Please recall the formula. In the last 2 slides, we have explained number of questions, problems on harmonic mean. And you could see that in case of the calculation of harmonic mean, all the observations are considered. We are actually getting the reciprocal of each of the observation and we are summing it up. We are adding them in the denominator. That is the process. But in this method, we are considering and including all observations, provided it is non-zero. So therefore, just like arithmetic mean and geometric mean, it is definitely clear for all of you to understand that harmonic mean is based on all observations. Okay. Next, harmonic mean can also be used for further analysis, for further numerical or algebraic treatment. That means it is very flexible, just like arithmetic mean and geometric mean. And the most important advantage or the winning feature, the unique point, proposition of harmonic mean is that it is most preferred when we are trying to find out the average of certain numbers which are like ratios and rates. So these are the 3 important advantages. Proceeding now to the disadvantages or the restrictions. Yes, for many people, harmonic mean or the calculation of harmonic mean or the concept of harmonic progression might be a little difficult to understand. It may not be readily understood. Plus, it is true that in case of large numbers, say you are given 15, 20, 30 variables, getting the harmonic mean, doing the calculation is definitely more tedious than what we face in case of arithmetic mean. So even for the concept purpose, understanding as well as the calculation, harmonic mean is a little difficult to comprehend, to absorb when you compare it with arithmetic mean. So definitely we agree to point number one. The second question is, it is usually a value which may not be a member of the given set of numbers. Yes. So we arrive at a value which may not be a specific number in the given set. Now we see it cannot be calculated when there are both negative and positive values in a series. Yes, technically speaking, or one or more values in zero. So the moment we have zero, yeah, if you have a negative number, we can get the reciprocal, but ultimately, in case of calculations involving central tendency, if we have situations where we are facing certain values which are negative or which include zero, then to be on the safer side, it is always preferable to use arithmetic mean. But in case we have non-zero numbers, definitely harmonic mean can be preferred, can be used with a certain level of accuracy. Okay. Now we have the weighted average. So as we saw in the case of weighted AM, sigma Wi xi divided by sigma W, where W is the Wi is the individual weights which are given. In case of the geometric mean, weighted geometric mean, we have discussed. There we have a different approach. And for weighted harmonic mean, we have seen that in the numerator, we will have the total weights, total frequency, that is sigma W. And in the denominator, we will have W1 by X1. That is the frequency of first variable divided by the first variable plus frequency of second variable by the second variable, and so on. Lastly, so we have completed the discussion of geometric mean and harmonic mean, including the formula. In both cases, first case we have discussed is where there are no frequencies, and number two, in case of frequency distribution, how the formula will be modified, that we have explained. Parallelly, we have discussed about the situations where geometric mean and harmonic mean should be used. And additional areas we have discussed are the advantages and the disadvantages along with the examples. Now we proceed to look at the relation. Since we are almost towards the end of the discussion on the measures of central tendency, now we will look at some very practical and handy, easy to use, useful relations between arithmetic mean, geometric mean, and harmonic mean. All three of these means, arithmetic AM, GM, and HM, they are important examples of average. Average, now we can say that it can have three types of meaning: AM, GM, and HM. From the overall conceptual framework, even GM gives us some sort of average. Median gives us positional average. But there are some interrelationships between AM, GM, and HM. In the previous session, when we were delving deep into mean, mode, and of course we cover median, you will remember that there was a formula we were discussing which includes mean, median, and mode. So mean minus mode equal to 3 into mean minus median. That means a formula which connects all the three parameters, mean, median, and mode. Of course, here mean signifying arithmetic mean. Now we look at another two very important interrelationships. But this time we are not considering median or mode. Here the discussion is absolutely limited to AM, GM, and HM, that is arithmetic mean, geometric mean, and harmonic mean. Relation number one. The arithmetic mean will never be less than geometric mean for any given numbers, and geometric mean will never be less than harmonic mean. So the relation number one. So dear students, please understand and keep these important relationships in mind, because based on these, logic, statements, parameters, relationship, you will be facing questions in the exam. So the first relation is AM shall always be greater than equal to GM. In turn, GM will be always greater than equal to harmonic mean, HM. This is the first relation. Another example, just to reinforce your understanding and concept from 14.1.17. This question is very interesting and important because it asks you to calculate all the three types of mean. So we have to calculate AM, GM and HM. Numbers, there are 4 numbers given, 6, 8, 12 and 36. So AM, just have a quick glance. I'm sure it's clear. We get the value, the sum of all the numbers and divide by the total number, that is 4 total number variables. GM, we are finding out the fourth root of the product of these numbers. And in case of harmonic mean, we first write the number of variables given. Here we have 4 variables, 6, 8, 12 and 36, 4 values. So 4, n equal to 4, we write 4 in the numerator. In the denominator, you can see we are just adding the reciprocal of these 4 numbers. So in the denominator, you have 1 by 6 plus 1 by 8 plus 1 by 12 plus 1 by 36, which is nothing but the reciprocal of the given 4 numbers. Now the second relationship, if all the observations taken by a variable are constant, that means the number x does not vary. Say it assumes only one value and the value say is k, x is equal to k. Then the harmonic mean of the observations will be k. Because if all the observations are k and there are n observations, so in the numerator, what will I write? I will write n. In the denominator, I will write there are n observations. Each of the observation has the value of k. So in the numerator, I will write n. In the denominator, I will write 1 by k plus 1 by k n times. That means I will get n divided by k in the denominator. And if you just transpose it, what you get is ultimately you are left only with k. So answer will be that the harmonic mean of a set of variables, each having the value of k, the harmonic mean also will be equal to k. And then, as we have seen, that if there are 2 groups, so you have 2 groups of data set. And in the first group, there are n1 observations. And in the next group, we have n2 observations. In the first data set, the harmonic mean is h1. And in the second data set, harmonic mean is h2. So the combined, what will be the combined harmonic mean? So this will be given. Logically, it follows. In the numerator, we will write the total frequency n1 plus n2. And in the denominator, based on our earlier discussion so far, we know that in the denominator, in case of frequency distribution, the sign which is shown is sigma fi divided by xi, which means the fraction which we see in the denominator here, the numerator of the fraction will be the frequency. Accordingly, we have n1 by h1 plus n2 by h2. This will be the denominator. So these are the important interrelationships. Now, the last but not the least, but please note, dear students, that this relationship which I am about to explain, and you can already see it has come up on the slide, this is going to be possible, it will hold good only when we have 2 positive numbers a and b. So it says that for any 2 positive numbers a and b, the arithmetic mean of these 2 numbers, if you multiply that by the harmonic mean of these 2 numbers, what you get is the square of the geometric mean of the same 2 numbers. That means for 2 numbers which are positive, any two positive numbers, say A and B, AM into HM will give you GM square. That means in the exam, if you are given the harmonic mean of two numbers and you are given, say for example, the geometric mean of these two numbers, and the question says that please you are required to find out the arithmetic mean. So this is a critical relation among the three parameters AM, GM and HM, but please remember this is going to hold good only for cases where there are two positive numbers. The moment you have more than two numbers, 3, 4, 5, this relation will not hold good. It will not give you the correct answer. The relation will fail. The equation will not work. So this is only for any two positive numbers A and B. Now, dear students, we proceed to see some more examples. First, we see example 15, and we see the GM of the numbers 4, 12, 8, and 26. Just quick reinforcement, recap of your knowledge. The more you do and see the examples, the faster you will be able to recall, and your memory of these discussion, whatever we had, the quantification part, the formula part, as well as the technical discussion, you will be able to remember and recall. So here we have four numbers, 4, 12, 18, 26, number n equal to 4. So we have to find the fourth root of the product. And using logarithm, it comes out as the geometric mean comes to 12.25. Another interesting question which is given in example 14.1.19 of the study material says that given two positive numbers A and B, you have to prove that G square equal to AH. Exactly what I was discussing in the last slide. And then the question asks you, does the result hold for any set of observations? So this is exactly what I was requesting you to note down, that only in case of two numbers, but these two numbers need to be positive. The relation of these two numbers is that the arithmetic mean of these two numbers, if you multiply it with the harmonic mean of these two numbers, you will get the square of the geometric mean of these two numbers. But as the solution, you can see in the solution in the study material, it shows clearly how the equation proves to be correct. But it is given clearly at the end that the result holds good only for two positive numbers and not for any set of numbers. So it is not a general formula. It is a formula which will hold good only for two positive numbers. We proceed to the next example, number 24. We are on slide 11. We see the next example now, and we look at the question which says AM and GM of two observations are given, 30 and 18. Find the observations, also find the harmonic mean. So using simple basic algebra, which you already have covered and you have good knowledge of that. So we can see there's a coming to a quadratic equation is formed, and from there we get y equal to 54 and x comes to 6, or it can be y 6 and x 54. So since the observations are obtained 6 and 54, from there automatically the harmonic mean is worked out. So this is also fairly easy. Just go through it once more and at your leisure, and then I'm sure you will be able to handle similar problems. We proceed now to check another question. If the arithmetic mean and harmonic mean of two numbers are 27 and 12, then what will be the GM? Please note this is a direct application of the principle we have seen earlier, that for two positive numbers, AM into HM will give you the square of the GM. So here it is given AM is 27 and your HM is 12. So the GM we have to find out. So we can see that the square of the GM square will be equal to the product of the AM and HM. So arithmetic mean into harmonic mean gives us the square of the geometric mean. So, which means GM in this case will be the square root of 27 into 12. So options which are given, let us see the four options given. So if you work it out, you will find 27 into 12, you need to find the square root because there are two numbers. So if you break it down, 27 you can write as 3 cube, and then 12 can be written as 3 into 2 square. So once you find the square root, you get 18. So the correct answer for this question will be 18. So this is also a previous question from the previous MTP. Finally, we have a quick recap of this is the closing. We come to the closing part of the discussion. AMGMHM, the best measure of central tendency usually is the arithmetic mean. On the right hand side, you can see another very important relationship of mean, median, and mode. So in this particular chapter, unit 1 of chapter 14, we have not only discussed about the different measures of central tendency. Now you are all having, I'm sure, a very clear idea not only about the concepts of AM, GM, HM, or median, or quartile, or mode, but additionally now you are armed with the knowledge of the relationship between these parameters. So mean, median, and mode are connected through the formula mean minus mode equal to 3 into mean minus median. And we have already observed and gone through the relationship, different formula, which captures the relationship between AM, GM, and HM. Now coming to the final conclusion as to which one is the best, which one is the superior, most superior. So we see AM comes out as a winner perhaps because yes, it is a best measure. It is defined rigidly. It is based on all observations, easy to understand, easier to calculate, and it can be used for further algebraic treatment. However, please remember, in case of a frequency distribution, and if you have an open-end classification, mean cannot be calculated. Mean cannot be used. It will not be advisable to use mean. There, the most pragmatic, practical, and realistic approach would be to use median, because median is not concerned with the extreme values, left or right side. We are ultimately going to arrange the values in ascending or descending order, and median critically looks at the values which are in the middle of this distribution. So in case of open-end classification, or in case of extremely high values, extreme values, median will not be affected. Arithmetic mean is extremely sensitive to outliers. Outliers is exactly what I was mentioning, extreme values. Still, it is the most stable against sampling fluctuations. Similarly, like arithmetic mean, median is rigidly defined. We know the middlemost value. Quite easy to compute, to understand and compute. For example, if number of observations is odd, so and it is n equal to n and n is odd, so we know n plus 1 by 2. If it is even, then we have another approach. But median, even though it is flexible in certain circumstances, median is not based on all observations. Plus, median cannot be used for further mathematical treatment or for further algebraic analysis. At the same time, median is highly resistant to extreme values. Exactly this is what makes median the most preferred measure of central tendency, because it is not resistant at all to extreme values. So in certain circumstances, specific cases, median, just because of this particular quality, might be the most appropriate. But overall, if we look at all the different measures of central tendency, arithmetic mean wins in most of the parameters, in most of the requirements. Mode is definitely useful in different type of categorical frequency distributions, but it can be affected by sampling fluctuations. So at the end, we see median is more affected by sampling fluctuations as compared to mean. Overall stability, easy to understand, easy to calculate, whether it's based on all observations. So if you look at all the check boxes, if you tick all the check boxes for arithmetic mean, for geometric mean, for harmonic mean, for median and mode, now that we are coming to the conclusion, we are looking at all the measures we have covered so far according to our curriculum regarding central tendency. We see that AM emerges as one of the winner, as perhaps the most popular or most appropriate in majority of the circumstances. Having said that, we must also notice and understand that even though AM by nature is perhaps the most easy to understand, has the maximum practical applications, easy to compute, it can handle observations which are zero, it is comfortable even with observations which are negative value. But we have seen that if any observation is zero, then GM and HM will not give the right answer, will in fact cannot be used. GM or HM cannot be used in such a scenario. So overall, no doubt AM appears to be the winner. It is also rigidly defined. On the other hand, GM and HM are a little more difficult to understand and perhaps more difficult to calculate when the number of observations becomes bigger and each of the observations have certain frequency. Then the calculations become tedious. Even in basic calculations of geometric mean, logarithm has to be used. So this makes GM, geometric mean, a little complex when it comes to computation. Lastly, we end with the concept of skewness, and after this we shall proceed to a number of questions from the exercises as well as from the MTP and RTP. So the last concept of importance so far as this particular unit of chapter 14 is concerned is the skewness. So now that we have discussed in details about mean, all the three parameters, arithmetic mean, geometric mean, harmonic mean, median and mode, plus quartiles, deciles, percentiles. So now we look at certain scenarios. What is skewness? So skewness means the degree of asymmetry of a distribution. What is positive skewed? If you look at the graph here, the two examples, you will understand instantly what is meant by skewness. And please remember, skewness is a term which you will be using and applying throughout your career, even as a professional chartered accountant, because we have to deal a lot with data, distributions of data. And nowadays, data analytics, data science, what does it do? It tries to identify the relationship between data. So as we all know, and we definitely feel that data is the new oil. But then only raw data is not enough. You have to sort the data. You have to analyze the data. You have to understand the existing relationship between different data. And from there, a particular AI tool or an AI model or a predictive analytics model will, ideally, what will it give you? It will project. It will predict. But it is based on existing analysis, that what is the historical trend of the data, what are the interrelationships, and therefore mean, median and mode are connected, as we saw. Similarly, AM, GM and HM also have certain relationships. So in case of a particular set of data, observations, if you see, once you plot the data, you get a graph. Now please remember the first session we had on statistics, statistical description of data. So there we covered important concepts explaining in details line diagram, histogram, bar chart, histogram. frequency polygon, and then frequency curve, ogive. I'm sure you recall your understanding of these important terms and their concepts. So here you see a graph on the left side where you can see mean comes first and then median and then mode. Now mode means the highest frequency. So if you see the graph, it is not symmetric. That means it is asymmetric. Asymmetric means not symmetric. But a graph, which is a bell shape, you remember we were also explaining different types of curves. 4 curves, I think, if you remember correctly. We had discussed about the bell-shaped curve, which is seen as a symmetric curve. Later on, you will see that the normal distribution is the example of, it's a continuous probability distribution. It has the bell-shaped curve. It is denoted by the bell-shaped curve. Bell-shaped curve means it is absolutely supposed to be absolutely symmetric about the axis. But there can be some lack of symmetry, asymmetry as we call it. So this asymmetric curve, first example you see where median comes in the middle, mode is on the right side and mean is on the extreme left. That means mean is less than median and median is less than mode. So this graph will be, you can see, it is tapering towards the left side. It is called left skewed, also known as negative skewness. On the other hand, kindly observe, dear students, the slide. We go to the right side diagram. If you look at the diagram on the right side, you can see that here mode comes first and then median and then mean. Of course, median will be in the middle. But if you see, the first and third positions are getting interchanged. So when mean is in the first position, that means mean is the lowest, median is the middle, and mode is on the right hand side. That means modal value is the highest here. The highest value you can see. So this gives us a skew towards the left. It tapers the tail. You can see the tail of the curve lingers and extends to the left hand side. This is negative skewness. On the other hand, you can see the right hand skew, also known as the positive skew. And that is where we find mean has the highest value. That means mean, in case of this particular item, the first scenario, what we see is, in case of the skew, when you have a left skew, in case of negative skew, we can see that mean is less than median and median is less than mode. And on the right hand side, we can see mode is less than median and median definitely here is less than mean. So please note that there are 2 types of skewness. Skewness means any lack of symmetry. So we refer to it as asymmetry, not symmetry, not symmetrical. And if there are 2 types, so we can have a positive skewness, also referred to as right hand skew, and it can be a negative skewness, which means it's a left hand skew. Now we move to the important relation, empirical relation, as I think we have done many of the relations here. Just a quick recap: mean minus mode equal to 3 into mean minus median. And before we go to the exercises, please see the last relationship, that if y equal to a plus bx, the mode of y will be equal to a plus b into the mode of x. Why? Because we see that in case of mean, median, and mode, they are affected due to a change of origin as well as a change of scale. So based on these 2 formula, important formula for our exam, let us see the first question. For a moderately skewed distribution of marks for a group of 200 students, the mean marks and the median marks are given. You have to find the modal mark. That means number of students 200, the mean is 55.6, the median is given 52.4. We need to find out the mode. So we apply the formula which we see on the top, mean minus mode equal to 3 into mean minus median, and putting the values in the equation, we arrive at the answer here is 46. As you can see, the working step-by-step working is given. So mean minus mode equals to 3 into mean minus median. From here, we get the value of mode, which is 3 into median minus 2 into mean. So that is the value of the mode. Accordingly, we get the solution. Mode equals 46. The next example, important question based on these two formula, you can see if y equal to 2 plus 1.5x. So there is a linear relationship we can see between x and y. Y is equal to 2 plus 1.5x. The mode of x is given. It is 15. We need to find the mode of y. So if you look at the relation number b, a and b, two relations are given on the slide. If you look at relation b, y equal to a plus bx, therefore the mode of y will be equal to a plus the mode of x multiplied by b. Because please remember, arithmetic mean, mode and median, these three measures of central tendency, they are affected both due to a change of origin as well as a change of scale. In this equation, y equal to 2 plus 1.5x, change of origin is reflected by the number 2 and change of scale is reflected by 1.5, which is the multiplier. So therefore, we just put the value of the mode of x. Mode of x is how much? 15. So in case of question number 2, since mode is affected by shift in origin and scale, so therefore the mode of y is equal to 2 plus 1.5 into the mode of x. Now the mode of x is given, it is 15. Therefore, once we calculate, you will arrive at the figure, a value of 24.5, which is the mode of y. So this is the important some of the examples, very appropriate for your exam preparation. Now we move to MCQ set A, questions from the set A of the chapter end exercises. The first one, measures of central tendency for a given set of observation. Measures what? So measures of central tendency, please look at the first question. Scatterness, central location, both A and B. So if you see measures of central tendency, they're not interested to find out the scatterness of the observation. This is a measure of dispersion. This we will take up later in the next unit. But central tendency talks about the central location of the observations. Therefore, option B is the right answer. Question number 2, while computing the arithmetic mean from a grouped frequency distribution, what do we need to assume? So dear students, in the earlier session and in the past few sessions, I have requested all the dear students in this platform to please focus not only on the numerical problems, but equally on the theory-based questions. So you can see many of the questions in set A, even if you look at the MTP, RTP and the past year's questions, you will find several questions which are based on theory. So I request all our dear students once again to please study the theory part, because a number of questions in the last few years have come from the theoretical portion. And if I'm not clear about the theory, for example, we talked about the theoretical, this is technical part, like the most appropriate situations where GM has to be used. What is the situation where HM cannot be used? What are the advantages and disadvantages of mean, median, mode, arithmetic mean, harmonic mean, geometric mean? So please be absolutely clear even on the theoretical part. So my request is, please handle and practice dealing with questions both from theory as well as the numerical questions, because any pattern, any type of questions can be expected. Here you can see, while number 2 is the theory question, while computing AM from a group frequency distribution, what do we assume? Classes are of equal length. Yes, that definitely. But number B, is it correct? Classes have equal frequency. No. We only assume that classes are of equal length. Please remember the formula for computing arithmetic mean from grouped frequency distribution. You may remember the formula was assumed mean plus sigma f into d, where d was the deviation from that particular assumed mean. And rest of the formula, I'm sure you have done numerical, you must have practiced numericals, you remember. So there the question came that in case of group frequency distribution, our first assumption is that the classes are of equal length. So option A is the right answer here. Question number 6, the presence of extreme observation does not affect. So this is yet another example of a very important question, but it is not from numerical. There's no numbers given. It is theoretical question, but theory means it is concept based, conceptual question. So the presence of extreme observations does not affect which of the above. Arithmetic mean will be affected, but median will not be affected. So question number 6, option B is the right answer. Question 16. Quartiles are the values driving a given set of observations into how many parts? Quartile means 4 parts, so we will go with option B. And please remember we had Q1 first quartile, second quartile, which is also the median, and third quartile Q3. Question number 17. What is the harmonic mean of two numbers A and B if the arithmetic mean is 25 and geometric mean is 10, provided A is greater than B and B is greater than 0? If B is greater than 0, obviously A is greater than 0 as well. So what is the harmonic mean of two numbers? So this is directly based on the discussions we had today when we covered discussions when we explained GM and HM. So we have AM given 25 and GM is given 10. We know the formula, but please remember this formula which I have discussed and now again referring right now applies only in a situation where we have two positive numbers. The moment you have 3 and more number of variables, this relation will not hold good. What is the relation? You remember AM into HM equal to square of GM. So here we have AM is 25, GM is 10. So the square of GM will be 10 square, which is 100. So arithmetic mean into harmonic mean equals 100. Arithmetic mean is 25. So what is harmonic mean? 100 divided by 25. So we arrive at the value 4. So harmonic mean equal to 4. So I hope it is clear, you are able to follow, and that's why we are going first through the discussions on the concept, why a particular measure of central tendency, what are the properties it has, what are the features, what are the winning features, and then we are moving to definitely the formula both for ungrouped as well as grouped frequency distributions, and finally we are having discussions on the advantages and disadvantages of each of the measure. We proceed to question number 10. Which of the following measure is difficult to compute? Difficult to compute relatively geometric mean. Out of the 4 options, GM is definitely difficult because of the use of logarithms. Number 11, we proceed. Which measure of central tendency considered for finding the average rates? Now, central tendency measure used for finding the average rates. Average rate, it is both GM and HM. We have already discussed and explained the rationale and the circumstances why GM and HM are both equally prominent measures, useful tools for finding the average rate. So here we will go for both GM and HM, which means option D. Number 12, for a moderately skewed distribution, which of the following relationship holds? Oh, this is a direct question on the formula. We have been discussing this quite often in the last session as well as in today's session. So I'm sure you have this formula. You must have memorized it by heart. it is mean minus mode equal to 3 into mean minus median. So for question 12, we are ticking option A. Quartiles are the values dividing a set of observations, obviously 4 parts. Then we have which of the following measures possess mathematical properties? AM, GM, HM, all of them have mathematical properties, of course, and they are amenable. That means they can be used for further algebraic treatment. So question number 18, I will go for all of these. So option D. Number 19, which of the following measures satisfies a linear relationship between two variables, that is y equal to a plus bx? And if you know the value of the mean of x and you know the value of a and b, you can easily find the mean of y. This logic holds good even for the median calculation as well as the mode calculation. Please remember, I have been repeating this particular sentence many times, that mean, median and mode, they are not, they are, if you see the relationship, if there is a change of origin, will mean, median and mode be affected? Answer is yes. If there is a change of scale, will mean, median and mode be affected? Answer is yes. So we can say if x and y are linked through a linear relationship, y equal to a plus bx, and we have observed that for mean, median and mode, the mode of y or the median of y will be equal to a plus the median of x. That means here it's a really linear relationship, and we are including both the shift of the origin as well as the shift of the scale. So all the three measures, mean, median and mode, satisfy linear relationship between x and y. The linear relationship between x and y, which is depicted through y equal to a plus bx, is satisfied by all of these three parameters, these three measures of central tendency. Question 20, which of the following measure is based on only 50% of the central values? The question itself contains the hint, and it is median, because 50% of the central values means it is the middle value. Middle value means median. We move to set B now. The question number 1, if there are 3 observations, 15, 20, 25, then the sum of the deviations from their AM. So now we are dealing with few important practical questions, numerical problems. So 3 observations are there. What is the sum of the deviation from their AM? 15, 20, 25. So you can see just by inspection that the arithmetic mean of 15, 20, 25, these 3 numbers will be how much? Will be 20. Now, what is the sum of the deviation from their AM? So deviation we know is x minus a. So here a is 20. So 15 minus 20 gives you minus 5. 20 minus 20 is 0. 25 minus 20 is plus 5. So if you add up, if you find the sum of these 3 deviations, these 3 values, the values we have got minus 5, 0 and plus 5, if you add them, you get 0. So 3 observations, 15, 20, 25, the sum of the deviation, answer is 0. Option A is the right answer. Question 2, what is the median of the following observation 5, 8, 6, 9, 11 and 4? So as we have discussed in the earlier session, for median calculation, we have to arrange the given numbers either in ascending order or in descending order, and then we need to see the number of variables, whether it's even or whether it's odd. So here we see there are 6 numbers ranging from 4, then 5, then 6, then 8, then 9 and 11. So if you arrange them in the ascending order, you get 4, 5, 6, 8, 9 and 11. And there are 6 numbers, so n equal to 6. That means n is even. So we apply the corresponding formula for finding median when the total number of observations is even, and consequently you will arrive at the value 7, option B. Question number 8, what is the value of the first quartile for observations 15, 18, 10, 20, 23? Important questions. Here again, the approach would be, what is the value of the first quartile for observation? So here we have to look at the values given, and then we have to see the total number. So what is the total number of values? 1, 2, 3, 4, 5, 2, 4, 6, 8. 8 values are given. So n is equal to 8. That means n plus 1 by 4. First quartile, Q1. First quartile, Q1, the formula is n plus 1 by 4. Second quartile formula is 2 into n plus 1 by 4. And third quartile, as you know, 3 into n plus 1 divided by 4. So here it is Q1. The question asks you to identify the value of the first quartile. So Q1, or the first quartile, equal to n plus 1 by 4. That means 2.25th term, which means the second term plus 0.25 into third term minus second term. So once we arrange the numbers and in ascending order, you will arrive at the answer will be 12.75. Option C is the right answer. The ninth question, you need to find the third decile for these numbers. So again, when it comes to decile, we know decile means it is the third decile. So 3 by 10 and into n plus 1. So that gives you the decile means divide by 10, and percentile means it is 100th part. So once we arrange these numbers, 8 numbers are given. Once you arrange them in ascending order, and then number n equal to 8. So as the formula says, n plus 1, that is 8 plus 1, but it's a decile, so 8 plus 1 by 10, and it is third decile. So ultimately it is 3 by 10 into 8 plus 1. So 3 by 10 into 8 plus 1 means 3 by 10 into 9. So accordingly, we have to find out the third decile. You will be able to find out. But first we have to first arrange them in ascending order. Next, question number 10. If there are two groups containing 30 observations and 20 observations, plus we have arithmetic mean. So this is based on grouping of the two given segments, and we have to find out the combined arithmetic mean. So two groups are given where we have the size is n1, n2. If you see, n1 is how much? 30, n2 is 20, and x1, x bar or x1 bar is 50. That means that arithmetic mean of first group is 50 and x2 bar is 60. So the arithmetic mean of second group is 60. We know the combined mean. The formula we know. That means we have to first find out n1 x1 plus n2 x2. Divide that by n1 plus n2. We get the combined mean, which comes to option C, 54. Question number 16. Two variables are given. Y equal to 2x minus 3. So it's a linear relationship between x and y. Median of x is given as 20. What is the median of y? We have already discussed this, that median, mode, and of course mean, they are affected by a shift in the origin as well as in the scale. Here, therefore, we have y equal to 2x minus 3. If the median of x is 20, then the median of y will be equal to 2 into median of x minus 3. That means we are including the impact of both the shift in the origin as well as the shift in the scale. Consequently, you get y equal to 2 into 20 minus 3. Now 2 into 20 is 40. So 40 minus 3 comes to 37. So this is question number 16. Another important question which is related to our discussion here, the mean salary of all employees is 20,500. Now the individual salary, the mean salary of male and female employees are given. That means two groups. You have one group of female employees and one group of male employees, and we have to find the percentage of males and females employed. So it's just the basic mathematics, and based on the formula which we have discussed and similar problems we have handled, and you can try it out and you will get the percentage as 70-30. Proceeding to further questions from set B, what is the modal value of the numbers? Numbers are given. You can see from the given numbers, only one number is there which repeats more than once, and this number is 10. So mode, as we know, deals with the highest frequency, that value, that number which has the highest frequency, and therefore 10 is the answer. Question number 4, what is the geometric mean of 8, 24 and 40? So we need to find the cube root, and of course GM for the numbers 8, 24 and 40. So 8 into 24 into 40, we get the cube root, and accordingly you can compute the answer. Question number 5, the harmonic mean of 2, 3 and 5 is how much? Just you need to calculate. Three numbers are given, so in the numerator we will have 3. In the denominator we will have 1 by 2 plus 1 by 3 plus 1 by 5, because we are getting the reciprocals of the given numbers. Accordingly, just work it out. We arrive at 2.9, which is option C. Question number 13, we have already done a very important question. What is the harmonic mean of 1, 1 by 2, 1 by 3 up to 1 by n? I was explaining it. Once again, you can see 1, 1 by 2, 1 by 3 up to 1 by n. So we need to find the reciprocals. The reciprocals of these numbers will be 1, 2, 3, 4 up to n. And therefore, in the numerator, you will have the number of variables. Here, the number of variables is n. So n comes to the numerator. In the denominator, you are having 1 plus 2 plus 3 up to n. And from the chapter of arithmetic progression, AP, you know the sum of these series. So it is n into n plus 1 by 2. Accordingly, we get the answer 2 divided by n plus 1. This question we have done earlier. If aircraft flying from point A to B, very similar questions we have handled and discussed in the session, earlier part of the session today. So one way it is moving 500 kilometers per hour and comes back at the rate of 700 kilometers. We need to find out the average speed. So this question does not tell you which method to apply, but looking at the question, you see it is a question of finding the average speed. Speed is a ratio. Please remember, speed is a ratio of distance divided by time. So we will apply harmonic mean, and we, using HM, we arrive at 583.33. Okay. We will come to the next question. We have, if x and y are related by x minus y minus 10 equal to 0. So we are given this relation x minus y minus 10 equal to 0. Just try and solve this one, number 18. So we are having x minus y minus 10 equal to 0. So we can put it in this way. We can write y equal to x minus 10. Just transposing y. It is, so y equal to x minus 10, and we are given mode of x is 23. If the mode of x is 23, then the mode of y is very simple, 23. Mode of x is 23, and the equation is y equal to x minus 10. So the mode of y will be equal to the mode of x minus 10. That is the relation, y equal to x minus 10. So 23 minus 10 means it is 13. Option B will be the right answer for question 18. Number 19, geometric mean of x is 10, geometric mean of y is 15. Then the geometric mean of xy will be what? We have already covered this formula and explained the working of this principle. So the product of two numbers, here we have one number is 10x and the other number is y. We have to find the GM of xy. So the GM of xy will be simply equal to the product of the individual geometric mean. That means it will be the product of the GM of x and the GM of y. That means 10 multiplied by 15, you get 150. 20th question, very similar to what we have done, many number of problems on similar lines. Y equal to 3 plus 1.5x. Mode of x is given. So very frequent type of pattern of question, and this comes often in the past year's questions. If you see, you will find similar questions coming in several attempts, several terms. So y is 3 plus 1.5x, mode of x is 20. What is the mode of y? So the mode of y will be equal to 3 plus 1 by 1.5 into the mode of x, which is 20 given. So, and the relation, the reason being that mode is affected due to a shift of origin and scale. So accordingly, we have 3 plus 1.5 into 20, which gives us 1.5 into 20 is 30. 30 plus 3 is 33. Answer is 33. Some more theory questions coming in the last few years, last 14, 15 years. Just quickly looking at some of the theory questions. For a shoemaker, which one of the following measure is most suitable? Shoe sizes, well, it is mode. Then rank of the kth decile. So it's based directly on the formula. Now kth decile means obviously it is k by 10 into n plus 1, because decile formula is in general, if you see, n plus 1 divided by 10 into the particular decile number. Question 3, the third quarter is also known as what? The third quarter, the third quartile, if you see, it is also known as the upper quarter. Q3 is known as the upper quarter. Q1 is referred to as the lower quarter. Question 4, dash is known as positional average. Many times we have discussed this. Why median is called positional average? So obviously option A is the right answer. Next question, number 5, the average discovers what? Uniformity and variability, variability and uniformity of distribution. So uniformity in variability will be the correct answer. Next, we have number 6, median is what? Median is obviously the midpoint. Option B, therefore, is the right answer. Number 7, mode is the value which is what? Mode is the value which is occurring most likely or most frequently. So option B. Question number 8, the middlemost value of a frequency distribution is known as what? Yes, now I'm sure all of you are clear, it's median. Question number 9, let us see. So we look at question number 9. The first quarter is known as what? First quarter is known as the lower quarter. Q1 is the lower quarter. Looking at the next lot of questions. So I have divided the last part of our discussion presentation today into theory, just to emphasize and once again request all dear students here to focus equally on the theory questions, and definitely you prepare for the numerical practical questions as well. Question number 10, dash is the value of the observation having maximum frequency. It is mode. Relation between AM, GM and HM. We have discussed it. AM is always greater than or equal to GM, always greater than or equal to HM. So option A is the right answer. 12th question, median is the value of a variable which divides the whole statistical distribution into how many parts? Median is middle. So undoubtedly it divides the entire distribution into left side and right side, lower and higher. That means two sides. Question 13, for a frequency distribution, median Q2, fifth decile D5 and percentile, which percentile has the same value? Lovely question. We know median is referred to as the second quarter, Q2. We have also discussed and explained why the fifth decile, D5, is equal to the median. Now the question is, which particular percentile is the median? Median means 50th position. So which percentile? It has to be the 50th percentile, because a percentile divides the whole population into 1 by 100. One percentile means 1 by 100. So median means 50 by 100. That means it is the 50th percentile. We proceed now to 14th question, empirical relation between mean, median and mode. So please see the number of questions coming on the theoretical part. Yes, mean minus mode. It is 3 into mean minus median, option A. Question 15, harmonic mean is the reciprocal of the what? So harmonic mean of a set of observations is the reciprocal of the AM of the reciprocal values of the observations. As we have discussed, both harmonic progression and harmonic mean. Question 16, the measure of central tendency of a statistical data which takes into account all the data. All the data, the measure of central tendency which takes into account all the data, definitely mean is the most appropriate answer, mean. Number 17, the cumulative frequency is required to find out which of the following. Cumulative frequency is used to find out, if you remember right from the first session on statistics, please think of ogive. Now, ogive means cumulative frequency. It is plotted in a graph. And from the ogive, you may kindly remember that we were discussing that from the ogive, now it can be less than and more than ogive, the intersection point indicates the median. So question number 17 answer is option B, which is median. We go to the next lot of questions, which as you can see are the numerical questions. The first question, algebraic sum of deviations of 10 observations from the constant C is -14 and the AM is 7.6. You have to find C. So here we apply the formula of assumed mean. Arithmetic mean, you can see, is we will take the constant C and then the deviation from C, and accordingly the value of C works out to 9. That is option C is the right answer. Question 2. If the HM of 4, X and 6 is 6, what is the value of X? Simple formula, we have done number of questions on HM. So question number 2, you can see there are 3 observations, 4, 6 and 4x and 6. 3 observations. So in the numerator we will put 3. In the denominator we will get the reciprocal. So we will have 1 by 4 plus 1 by x, and then we have 1 by 6, and accordingly we get x equal to 12. Option number B is the right answer. Up next is question 3, AM and GM of 2 numbers. So all possible questions from all the formula in this chapter and all mathematical relationships we are trying to include in our discussion and solve them. Question 3, you can see past year question. AM and GM of 2 numbers are 10 and 6. What are the numbers? So AM and GM of 2 numbers are given. What are the numbers? So question number 3. So we know that in case of this question, so we have to work out using quadratic equation, and you will be getting 2 and 18. So therefore, option A will be the right answer for question 3. So here you just need to frame the equation. So we have GM is given, GM is 6. So xy, square root of xy, square root of the product of x and y, that means xy to the power half will be equal to 6. That means xy is 36. You get one relation, and from the AM relation, that is x plus y divided by 2, you get 10. So from these two equations, once you solve, you arrive at 2 and 18. Okay, we are proceeding now to the last part of our discussion. We have the RTP 2025 and 26. We are on slide 21 now. Question 20, for open-end classification, which of the following is the best measure? Well, for open-end classifications, definitely median will be the best measure. Question 21, if each item is reduced by 12, the AM, what will happen to the arithmetic mean? Yes, we know arithmetic mean is affected due to a change of origin and also due to a change of scale. Here, each item is reduced by 12. That means we are shifting the origin by 12. So it is basically reducing it by 12. We are shifting it. So the AM also will be reduced by 12. Same relation. The 22nd question on this slide, the mean salary of a group of 40 female workers is given, and for a group of 60 male workers are given. What is the combined salary? That means two groups, N1, N2 is given. N1, that is female, 40, N1 is 40, and the average is, the mean is 5,200. And N2, that is male workers, 60, and the average for the male workers is 6,800. We need to find the combined, what is the combined salary? Right, so the question number, this is question number 22. So just by applying the formula N1x1 plus N2x2 divided by N1 plus N2, you get the combined average, combined mean. 23rd question, before that, we will see 20th. Yes, 20 is median. We are just counter checking. 21st question, it will be reduced by 12. And for 22nd question, we will just exactly what I was referring to the formula. Here we have N1 into X1 plus N2, that is 60 into 6800 X2 divided by N1 plus N2. Please note N1 is 40, N2 is 60. So N1 plus N2 is 100. So therefore, we divide this particular product and the sum, of course, individual product and the sum of these products divided by 100. So we get 6160, which is option A. Question 23, the average age of 15 students is 15 years. Average age of 15 students is 15 years. So the total age is 15 into 15, that is 225. Out of these, the average age of 5 students is 14 years. 5 students average age is 14 years. So the total age of the 5 students is 14 into 5, that is 70. Then it is given other 9 students, their average, for the other 9 students, their average is 16 years. So for the remaining or the next 9 students, the average is 16. So the total age of the 9 students is 16 into 9. 16 into 9 is 144. So therefore, the question is, what is the age of the 15th student? So we have got the total age of the 5 students, we are getting 70. I'm just working out. The total age of 9 students is 144. If I add them, I am getting 214 is the total age of 5 and 9, 14 students. 14 students total age comes to 214. Whereas it is given that the total age of the 15 students, we have worked it out. 15 students average is 15 years. So the total age, the sum of the ages of the 15 students is 15 into 15, which is 225. But the sum of the age of the 14 students is 214. So you are getting it. Total age of 15 students is 225. Total age of 14 students comes to 214. Therefore, the 15th student age has to be how much? 225 minus 214. So it is 11 years. So therefore, naturally, we are opting for the first option given. Option A is the right answer. Question number 21. The quartiles of a variable are given 45, 52, 65. Its quartile deviation. You are aware, and we have discussed this. Quartile deviation means Q3 minus Q1 by 2 divided by 2. So we have the third quartile 65 and the first quartile is 45. So Q3 minus Q1 comes to 65 minus 45, which is 20, divided by 2, we get 10. So 21st question, option A is the right answer. 23rd question, the median of 27, 30, you can see a series of numbers. Please first classify them, arrange them in ascending order, and thereafter we will get the median, the middlemost value. So here we see we have 1, 2, 3, 4, 5, 6, 7 numbers. Once you arrange them, you will get the middle number and you can get the right option. 24th question, if the relationship between x and y is given, 4x minus 6y equal to 13. Median of x is given. So 4x minus 6y equal to 13, which means a very common type of problem you can see, which is repeated, this pattern of problems. So going to the solution, 21st question, we solved it. It was half of the Q3 minus Q1. That means half of 20, which is 10. The next question on ascending order, once you arrange, there were 7 numbers and median will be the 4th term because n is 7. So n plus 1 by 2. 7 plus 1 by 2, that is 8 by 2. That means fourth item, which is 37. For the next question, 24th, 4x minus 6y equal to 13. So we can arrange it and write that y we can write is 4x by 6 minus 13 by 6 on transposing. So if that be the case, and we know the median is given, median is 16. So therefore, It is 4 into 16 by 6 minus 13 by 6, and the answer comes to 8.5. Option C is the right answer. Last question, if x and y are related, same pattern, 3x minus 4y is equal to 20, and the quartile deviation of x is 12, then the quartile deviation of y is how much? Please remember that for quartile deviation, it is unaffected by a change of origin. It is only affected by a change of scale. Here we have 3x minus 4y equal to 20. So 3x minus 4y equal to 20, we can write it as 4y equal to 3x minus 20. That means y is 3 by 4x minus 20 by 4. That means it is 3 by 4x minus 5. Since quartile deviation is affected due to a shift of scale, it is not affected by a change or a shift of origin. Therefore, we will just apply that 3 by 4, the multiplier, and it is given that quartile deviation of x is 12. So the quartile deviation of y will be 12 into 3 by 4. And therefore, we will get 9 as the right answer. We look at the last few questions. RTP, very, very important. September 2026. That's why I kept this at the end. Average salary of the whole employees of a company is 400 per day. Average salary of officers is given. That of the clerks is given. If the number of officers is 40, find the number of clerks in the company. Let us first see the questions and then we see the solution. Question number 18. This is D6. So for question number 18, we just need to arrange the numbers in increasing order, and then we get the total number. How many variables are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 variables are there. You need to find the sixth decile. That means here D6 is equal to 6 by 10 into 10 plus 1, because n plus 1. N is 10 here, and then you can calculate. 23rd question. Very similar relation, linear relation between x and y. So it is given 5x plus 6y plus 9 is 0. The mean of x is 6. What is the mean of y? So these are similar questions, and but this is September 2026 RTP, so critically important for us. Question number 5, the number of clerks. You can work it out based on the simple formula we have discussed. It will come out to 200. Question number 18, D6. So as I was mentioning, once you arrange the data in the ascending order, you will get D6 means it is 6 by 10 into n plus 1. Here n is 10. So it is 6 by 10 into 11. That means 6 by 10 into 11th observation. It comes to 6.6th observation. 6.6th observation means the 6th observation plus 0.6 into 7th observation minus 6th observation. Accordingly, it comes to 12.40. 23rd question, just rearrangement of the relationship which is given. Y equal to minus 3 by 2 minus 56x. Since it is a question of mean, and mean is affected both by a change of origin and by a change of scale, so therefore working out, you will get the mean of y will be equal to first the change of origin minus 3 by 2. Then we introduce the second parameter, change of scale. So minus 3 by 2 minus 5 by 6 into the mean of x. Mean of x is 6. So the expression ultimately comes to minus 13.2, that is minus 6.5, which means option C is the right answer. So at the end, we have completed all necessary questions within the time frame, of course, and we have covered and discussed in details arithmetic mean, geometric mean, harmonic mean. Please see the chart once again. Central tendency, very important chapter, unit of chapter 14. Different measures. We have mean, median, and mode. We have gone into the details of arithmetic mean, properties, weighted arithmetic mean, advantages, disadvantages. Similar discussions we have done for geometric mean and harmonic mean. For median, we looked into the important properties of the median. how median focuses on the middlemost values. As a result, median remains unaffected by extreme values. Also, median is not affected even in case of open-end classifications. Parallelly, additionally, we covered quartiles, number of problems on quartiles, quartile deviation, decile, and percentile, and mode, including the properties of mode and calculation of mode, both for ungrouped as well as for grouped frequency distributions. Once again, as we close, a snapshot of the important formula, which definitely all of you by now, you must have learned it by heart, and you must have started practicing questions, solving problems based on these important formula of mean, median, and mode. Plus, please do remember what we covered today in details. Geometric mean is the nth root of the product of the numbers. So x1 into x2 up to xn, the nth root of that. When there are two numbers, we saw that for exactly two numbers a and b, the geometric mean will be equal to the square root of the product of the numbers. Plus, for harmonic mean, we have examined both the formula, that is without frequency as well as for distributions with frequency, and the formula once again given for your recap. And lastly, when we have two numbers a and b, the harmonic mean will work out to 2ab divided by a plus b. To conclude, for two numbers, specifically when we have two positive numbers a and b, the product of the arithmetic mean of the two numbers and the harmonic mean of these two numbers will be equal to the square of the geometric mean of these two numbers. So please remember this relationship as well, but kindly do note that this is going to hold good only for two positive numbers. And of course, the empirical relation that arithmetic mean is always greater than or equal to geometric mean, which is greater than or equal to harmonic mean. Additionally, we have discussed about, if you remember, about the curve, symmetric curve, and the skewness, positive skewness as well as negative skewness. Please do remember that. See the video once again, go through the important questions we have discussed. Please revisit and revise the important technical and theoretical principles, the relationships of each of these measures of central tendency. Keep practicing. In the next session, we shall commence with Unit 2 of Chapter 14, which will deal with dispersion, different measures of dispersion. So on that note, thanking you once again for your participation and for your active preparation and the hard work I'm sure you're putting in. See you next day. Till then, keep practicing and take care.